Welcome to the video, guys. This is my first time ever running the stump grinder. I still had a lot of things that were very temporary at this time. The stump was totally rotten and I ripped through that bad boy in just a minute or two and really thought this machine was amazing. I didn't really conceive that how rotten this stump was, and so it was a false portrayal of what the machine could do. But I had little issues with the hydraulic system. The lift ram was the wrong size. There were some issues with the controls. It was just the tensioner wasn't set up properly. I forgot to tension it here. So there were a couple different things. The sweep speed was out of control. I couldn't figure out how to get the sweep speed correct. And so there were some hiccups for sure, but we tuned up after this and got into a much better place. You'll see that in a second. Right here, I actually couldn't lift the head back up. That cylinder didn't have enough power. I had to increase the system pressure and I was able to lift it, but you couldn't lower basically if you lowered the system pressure, then it wouldn't be able to do anything, and if you increased it, it would smoke out that belt. So we did some good work on that. I'll show you that. In this scene here, I'm basically on my second, third maybe stump, and my temporary welding for the sweep cylinder is about to fail, and you'll see that head just swing over to the side. So there was a little bit of additional work that needed to go into that, and that actually has repeatedly demonstrated it takes a lot of abuse. That component needs to be reinforced. It needs to be very strong. You can see here this head is jumping up and down a lot, and part of the problem is the tongue weight on the trailer is so low. Part of it is the speed of the sweep is too fast also. Alright, here's a little footage of us just doing the initial testing with the remote. We made a couple changes to set the sweep speed better and get that a little bit slower. So Mike's just figuring out where all these buttons are, but we have an operational remote here, so that's a great achievement. Also in this footage you can see that the tensioner mechanism is now on the right side of the machine. First and foremost, the engagement mechanism was better on this side. I actually had an issue with tensioning these belts because that front shaft was already as far forward as it would go, and these belts were going to need to be replaced to get the full tension. Additionally, I had an issue where you'd start the machine and then you'd go all the way around this cutter head while it was running, which is a little dangerous and nobody really wants to do that. Walk around, and I wanted to move the motor back because you can see, like, if you imagine the turntable is right between these two components here, and so all the weight is forward of that. I wanted to try to get the motor back. I didn't really accomplish that much, but I did tension this belt really good where there's no slippage on this belt. It does get a lot of abuse from where it's located right now. Not sure what it's crashing into, but this needs a shroud. So I took the mechanism off there, I put it on the other side. That works really well. So this now has like a chain to hold it back because that turnbuckle kept breaking. This turnbuckle is fine where it is. That's a good adjustment tool. I need to still come up with a better adjustment that doesn't break because this is a cast piece and it can break, but we'll keep running it for now. It doesn't like the vibration, but these belts do stay on this idler with the flange, even though they can move freely amongst themselves. So they don't take as much punishment as the fourplex type belt, surprisingly. So I went on Amazon, I bought this remote, which is $100, something Chinese, and there's tons of these on there on Amazon for not too much money, and they're decent, they work. This thing works from very far away. It's kind of funny because this is a fake antenna. It's not even attached to the board, but it works. So I use that, and you can run the remote or you can run these switches here. At the same time, I worked on the shroud actually, because this was abusing me with the pieces that were flying out. So I put this steel backing. That's going to be the piece that the the shroud is all attached to and everything, and we'll just work around this idler. But let's see what else. We changed the belt that goes into the pump to make that longer, I think, or I can't remember. We moved the motor that way, so I think we made that belt longer. And then put this weight here. This weight helps a lot with the balance of the trailer, but it was not doing everything that I needed. So I decided to make this tongue longer. That was kind of a 2-in-1 decision. It is also making it heavier up front. And so what's inside of this, what's attached to this right here is completely solid steel. It's a bunch of pieces welded together, but they go all the way in there. I can't even lift one end of it, so it's got to weigh more than 400 pounds. So the machine has become quite a monstrosity now, as you can see. It's very long, it's very, very unwieldy and huge. And there's a lot of wasted space up here, actually. I'm not very excited about that. We might come up with something for that area. You know, I could build out a platform here and use that to park a Bobcat on. I mean, it's just huge. It's huge and long. I don't know what I'm going to do, but it's getting heavier and heavier as I go. So the next stage is right now I have this piece of steel, and I'm having an issue where the front, I believe, is actually bowing down from the impact. I don't know if you can really tell. The camera, I don't know if the camera does it justice. There's a very slight bend in this front, or I guess it's the rearmost part there that this is attached to, and it's just a 1/4-inch steel, but this is a very heavy piece. And I know that on the chassis of the stump grinders that are bigger, they have like basically solid steel, 1-inch, 2-inch steel components down there, so those will be way stronger than this. So I need to at least bolster it and see if that helps. If bolstering it doesn't work, we're going to need to do some serious rebuilding, but hopefully this will do it. So this is just a piece of 3/8 by 5. I'm just going to weld that on there for rigidity and see if that works. I still have my 4th function unused on this, but I was thinking maybe I'd put a blade down here, because if I have a blade and I can retract 5 feet, I'll drop the blade and then I'll back up and it'll push the material. It'll probably be like a V-blade style, but I don't really know how to implement that. Might not be a good idea. It might be better to save that 4th function for something else. So it's just a thought right now. And then I think our hydraulic is going to be too small. I think we're going to need a bigger hydraulic tank. Partly the fluid gets so hot and warm when you run it. When you start really pushing a lot of fluid through, you're basically sweeping is all you're really doing, but you're doing other stuff only a little bit, but sweeping you're doing a lot. And this is such a small tank. I know there's like a ratio you're supposed to have for like the total system capacity to the tank. So I'll have to look into that. That's probably more of an engineering thing. Shouldn't be, hopefully not too hard to find. I also changed, so my power supply to the remote module had to be running off the ignition, because we didn't want the remote to be able to work all the time. So we ran it off the run position on the key, and then I realized you could still run up and hit this button right here. And so what if my kids come over and they're playing with this, and then one of the kids is over there? I don't want that. So I put it to the key switch, so now you can't do anything. And if you turn the key switch, of course, it'll actually lower because it will open that valve, see? So you see it going down. So yep, just keep this off. We'll be good to go. And then later, if I want to, I can actually put a remote start. There's the pink wire comes out inside this harness here now. But that pink wire, there's a button, like a double press you can do on the start button, and it'll actually run power to ignition. But the problem is this engine doesn't really allow like just a simplistic start like industrial diesel engine might, a glow plug or a grid heater style industrial engine where there's no preheat cycle, there's no chokes. I can't do that on this engine. So maybe in the future someday I'll have a different grinder that has an engine where you can do the remote start, but it's okay. I don't need to remote start this. I get out of the truck is going to be right there, and over here I could just start it, engage the wheel. I still have to engage the wheel, so I'm going to walk over here, do this, do that, and then I can come over and run it from the side, and it's really great. I did 5 stumps the other day. It took me no time. I was thinking also it might be good to have a camera somewhere. I don't know if right here, maybe even have like an arm that comes out and looks down, but a camera that would allow me to actually be in the truck. And so I'm in the truck, I have a remote, I have a 9-inch camera, like LCD that, or LED, you know, it's a screen I can watch the camera. They're like $250 for a camera. So I was thinking maybe I'd throw a camera out here somewhere. I just wouldn't want it to get broken, but a camera would help me get on the stumps too, so I'll probably still do that. But we're still kind of in like idea phase with these shrouds. Actually, the shrouds do a really good job. The only thing is I'll get dirt shooting up through here, so probably like just a piece of steel right there will be fine. Maybe at a slight angle and something not too thick, just to be there pretty much. This cylinder has to be able to move forward and down, so something is going to go there. I haven't figured it out yet. Might even be a piece of rubber. You know, rubber is easy to work with, and I've got some of that here. I've got still this big sheet, so I can slice up in a couple pieces for that, I'm sure. And then we might even do like a side rubber off of this fender a little bit, like one there and one on the other side, and that helps with the containment. But this machine doesn't really make a big mess, but there can be a little bit of mess. The trouble is that the head will come out all the way to over here, and so if you have any shroud right there on a metal piece, then it's going to crash and bend it. If you'll excuse me, I just have to weld this piece of steel on here really quick. Should only take about 20 seconds, but this took me a while because I put a lot of sticks into it. But you know, that structural stuff, it was all assumed, but you can't assume that. You have to really design that and engineer that for the weight of the machine that you're building. I sped this up for the sake of the viewers, but I was switching out my hoses to get everything ready for that cylinder. It was supposed to be there today or that day. And so then I had a person call me and they were far away, and I thought, what if there's a stump while I'm up there? I should prep this thing for work, even though it's just a possibility that I would use it to make money. I didn't make any money, but at least I got a little practice, and I learned about welding on a hydraulic system. So this will be interesting. I know everybody's already judging me for doing something extremely dangerous or not knowing how to do it properly, but at the end I just relieved the hydraulic system and let the fluid out, and then I was able to weld it. But every time you heat up the fluid, it jets out, and so you can't actually get a final seal because every time that weld is hot, it's allowing that material to push out when it's squirting. I'm going to show you guys the new changes that I made. So first and foremost, this large shiv, 11-inch, too big, or 12, I forget, 11 or 12, too big to go in the front, because when it was beside this wheel, it was really like colliding with the ground a lot, and I needed to have this metal backing here because this is actually going to have a shroud over it, which is out another inch away from the pulley. And if you look at the side view of this cutter, you can see I was losing, this cutter here, I was probably losing like a couple of the cutters, the ones that are farther in on the wheel. So I wanted this to be a smaller shiv. That's as small as I could get. So 9-inch, that's what I get. I probably could have gone to like a bigger one over here, and then I could have stayed smaller on this one, but it's fine. So I got a shiv that would go here because I didn't want to basically get the fancy bushing for that old pulley. So I just got this, and then I got one of these 4-plex belts. I forgot to get the cogged belt. So you're really supposed to have a cogged belt when you have a small pulley like this because it gets better contact, but these things have tremendous friction. It's much better than those old junky belts. These actually are some very old belts. These were on the old Bandit brush chipper, and these belts were dry rotted. Let's see if I can show you. You probably can't really tell, but just believe me, I could tell you, they're loaded with cracks. So the normal way that these tongues are done is that the cylinder and the tongue is all integrated into the actual chassis. So in through here, underneath the engine, through these frame rails, the tongue would basically be a long tube, and then that cylinder would be on the bottom. I chose to put it on the top because of risk that I thought I would mitigate by not having it on the bottom with ground clearance. What if I want to drive over a stump, for example? I could drive this whole machine over a stump. It's not really going to hit, once I tie these up and everything, these wires here, it's not really going to risk anything on the machine if I want to drive over a stump to get on it. But that cylinder can't be there. Absolutely out of the question. So I got myself a nice jack, because the jack I had was getting destroyed little by little. It was so twisted and bent, and it didn't really crank good, and the handle was damaged. So this didn't cost me much, and now I have a beautiful working jack. So before I did the double belt, I was having a problem with this still smoking belts. And what would happen is you would be running this, and I would raise this pressure up to make the machine achieve something. So like, for example, the tongue wouldn't retract or it wouldn't extend. And so to get the extra power I needed, I had to raise the system pressure. So loosen up this nut, which there's a better device for what this, but anyway, you're not supposed to really meddle with system pressure, okay? But for the purposes of fine-tuning the system, and then you turn this shaft right here, okay? And then you just turn that lock nut, and it stays there. As long as you just do finger tight, it stays there. But what would happen is I would raise the pressure for my tongue functionality, and then over here I go back to sweeping, and I've got my needle valve set correctly to the sweep speed I want. And then I'm sweeping, I'm going, and then I look down and this belt is smoking, and you can smell the vapor of the rubber, and the belt broke on a job site. We were grinding a big stump. I was very happy about that stump, but the belt broke. And then this head was down, and when that head is down, I mean, I was like really close to the ground. I was like a foot or two off the ground, and I wasn't happy about that, but I drove it like that because it wasn't coming down anymore. And I got another belt, and I got it together, and I spoke to a hydraulic shop, and they told me you go to a double if you can't, sorry about the focus guys, but they told me that you go to a double belt shiv if a single belt is not giving you enough traction to turn this pump. So what he basically implied was that probably the pump was not bad just because it was not turning, but that the belts weren't grabbing hard enough to properly pull it. So I went out and got extra. I got the double shivs and threw them on, and actually I got a very good lineup on this now. I don't know if you can tell, but I had trouble lining that up before. But these double shivs have a recessed core in there where the bushing goes. So it's back here kind of, and so it was able to stick out a little bit more. And even like this shaft, it was not like this was much deeper before because I had to have that shiv out more. But this, because like I said, it had that recessed bushing taper there, it was able to come out this way more, and that was the solution to my little problem. This belt actually, it's a different belt than the one I had on there. I already had a 4-plex belt, but it was a cogged belt and it was much shorter. So once I went to a big shiv here, of course, that's taking belt, right? So I would have actually had to move the engine more this way. I'll try to give you an idea where that slew ring is. Right now, the center of the slew ring is probably like the filter, where the filter mounts onto the motor right there. You can take a look here. So, all right, well, there's the bolt circle right there. It's a big bolt circle, you can see. So, yeah, there they go, see? So, the center probably is about where this oil drain cock is. So the problem was that this motor was already like on top of the slew ring. It wasn't even behind it, and you won't see that on a Carlton. You'll always see the motor a little bit back. So I just thought, I need to solve this problem. So I got a slightly longer belt. I had like some additional play here to move this back, and I really wish I had gone more, but there's a formula where you measure center to center, and then you just tell them the shiv size here and here, and then it tells you the length of belt that you need. And so I use that formula, just calculating for like roughly a couple inches more. I think I actually said 6 inches more, and it moved it 6 inches. So it effectively did what it was supposed to do, but I didn't want to be all the way over to here and then not be able to tension it, because if I did that, what am I going to do? This does not smoke out belts on the drive now. It bogs down the motor, which is what it's supposed to do, because if you're smoking belts, your belts are set wrong, okay? You want to transfer all the power of the motor into this wheel, and you want to transfer all the resistance of the wheel all the way back to the shaft, the output shaft on the motor. If you're losing anything anywhere, it's going to be on these belts, and that's going to be squealing, and that's how you know. So I was running this on a nice hard maple, I believe, and I had turned up this turnbuckle a lot. This is so hard now to turn. I can't even turn it by hand. I have to use a tool inside that slot. But I tightened up the turnbuckle. You can see that this belt is stretched out nicely. Let me see if I can get this here. So, and then even still, you can see that belt is still stretched. So, only thing is, you know, we couldn't set the belt tension quite as high with this 4-plex belt, because as soon as we put the 4-plex on, I'm just calling it that, okay? I don't know what it's actually called, but I like 4-plex. I like how it sounds, so that's what I'm going to say. But as soon as we put this on, I was setting my disengaged tension, okay? So I want my disengaged tension to be loose enough that I can grab this wheel and move it by hand. It's easier to turn backwards. I don't know why, but these shivs let me turn it backwards easier than they let me turn it forwards. So I'll grab this wheel and I'll hoist up on these teeth with my hands, with 2 hands, and I'll get this wheel to move around. And the reason that's important is because I need to be able to work on my teeth. And also because if you think about it, like, you've got to have slip somewhere when it's disengaged. Otherwise, when that cutter head is down in a root and it shuts off my motor, I don't have any way to start the motor up to lift the head, because I can't run the hydraulics without starting the motor, and I can't start the motor because it's linked straight to the cutter head. See the problem? So I have to have an actual real disengage here, right? So this is a pretty good disengage, but I need to be able to know that that wheel is able to be still while the engine is turning. It takes some torque to do that. It'll spin this shiv right here that has the least contact when it's loose like this. And this belt really should have been cogged, because the tiny little shivs I have here create kind of an arc. You see the arc? So you see it really doesn't want to be on that small of a radius, but it will. It will get used to it over time. I got this awesome remote right here, and this thing is amazing. You just hit the start button. So it looks like we're still having a problem where it's hard to establish the pressure correctly. So it needs a higher system pressure to extend that tongue when you're going over an obstacle. So to test it, I put this starter from an old truck into the path of the wheel, and I could not retract the cylinder. So it's kind of weird because you either run the system higher pressure. I guess there's probably a way to beat this. I'm not sure what the logic is yet, but what we need is higher pressure going to that cylinder and then lower pressure going to this one. But if somebody knows a way to do that, you could let me know. But basically I have to adjust this pressure. If it ever gets stuck, I'll adjust the pressure higher, and then when the pressure is high, I've noticed that this head pretty much always wants to go fast, and you could turn the needle valve down to almost nothing and that head will still be going fast. So we will have to figure something out with this. Maybe I need a different needle valve. Maybe this is the wrong one, but this remote is amazing. It's just a crane remote. You just hit this button and it turns off. As long as that switch is off, it can't turn this device on, so it can't drain my battery. It's also kind of a silly little thing, but I had to buy this muffler because the other muffler actually fell apart while we were driving down a bumpy road and it was all rusted. But I cut the tip like 4 inches off the tip because every time I was coming in my garage, I had to take that muffler off to clear this door. And I'm like, why would I keep doing this? Why am I struggling here? I'll just cut this thing shorter and make that problem go away. So now I can leave that on there all the time. We really need to put belt shrouds on this thing. That's going to be one of my next projects here. But I need something that goes and encapsulates all this and keeps that safe, because what was happening on this other belt was little chunks were coming inside. Let me see if I can find one. So there's like a pock mark right there. And if you flip it over, come on, look inside, you can see there's actually a big tear, a little tear right inside there where some chunk, a rock, a piece of mulch, a pebble, something went down in there. It went through in the web, you know, and this is like the backing. So it pushes through that backing, and it wouldn't happen on the individual belts, but this fourplex is infinitely better than individual belts. Much stronger, much better traction too. We had to reset a couple things over here. I put a bolt right here because when you would tighten this bearing right here, the whole thing would cock over, or actually it would pull up, and then that belt would hold it back, and then this one would come up towards me. And so now I figured out why they have a bolt going down on these bearings over here, and this bearing usually has one coming up, but they both have one coming up, and then this is the only one that I have going down. But actually I've seen them where they have bolts on all four, so going down and up on both bearings. But I just double checked it and made sure that this wheel looks mostly straight. It's definitely not straight. If you take a look at the whole cutter head, it's kind of cocked over, but I think maybe what I'll do is just put a couple spacers in there on this side right here, and probably that will fix it, because at least the position of the cutter wheel, because you can see, I don't know if you can see, but I can see that this shiv that's closer to me is cocked over this way, and I don't like that. I don't think that's healthy. So everything up until this point seems fine, but I don't know if it relates to the positioning of these tabs when I welded them in, or maybe it just has to do with warp, or maybe it has to do with, because there was a warp that happened on these flats, these flanges right here, where they went up like that, I believe. And I put these pieces inside there and I thought that would hold it, but I guess it didn't. So they're not actually on the same plane, and it has self-aligning bearings, so it'll keep that shaft in there where it's supposed to be as far as being able to go through both bearings and spin freely. But these bearings are not on the same plane as far as where they're mounted on the flanges. So I think what I'll do is I'll probably just drop this one down. I just need to make sure the mounting surface to this is a full mounting surface, because I don't think I would really want this bearing to be mounted with like washers up above it. It doesn't seem really healthy for the cast iron. I definitely want that to be pulling on a nice full plate there. So I might get a couple pieces cut and prep them and then put some holes, and then I'll just try to test it out and see what I can do there. Yeah, because otherwise really there's nothing else you can actually do here other than like fixing that or rebuilding the whole entire holder, like the whole shroud, and I don't really think that's necessary. I'm encountering a lot of material. I mean, this is from like some huge stumps. We put rubber right here in the middle, and I thought that was working pretty good, but where I actually think it's coming up through this hole right here. So that hole needs to get a plate welded onto it, and then I will probably end up putting something in this area right here as well. I'm not really sure, but definitely the shroud is key for this right here. It needs the backing, and then this thing is already touching right there, so I need to probably heat that up and bend it, or even remove it. I might remove it. That was going to be the mount for my shroud on this side, so I'm not sure how this is going to play out, but there's definitely going to be a shroud at the end of the day, and I'll need to do a little work on these connections on this pivot, because this pivot takes a lot of punishment, and I actually can see that my little sleeve I put in there is already broken. So we are going to come up with a solution for that works much better. Maybe a solid piece of steel, some large thick steel, and then put that collar inside of there instead. It's been very cool building this machine, but I've learned a very important life lesson. I've learned a couple of important life lessons. One is, don't underestimate engineers, real engineers, I mean, the inventors, not the guys with like a CAD drawing certificate or whatever. I mean people that are actually building something, because the engineers that make stuff, when we work on it and we're frustrated and angry because the engineers made it a certain way, hey, those guys were probably, whoever was building it and unbuilding it over and over and over again. They ran into troubles, they solved them, they solved another problem, and something popped up, and then they just kept doing that. And that's how you end up with a machine, is somebody eventually says, this is good enough to roll out. They've put a lot of time, a lot of work, a lot of money into it, and they need to earn. And when they have to have something roll out, even if it's like a mostly done prototype, they will still roll it out because they have to make money at that point, and they are feeling the squeeze. And people are excited about it, and they know, hey, we'll buy it, and then, if there's a problem, we can bring it back to those guys. So for my part, I've learned that building something and creating something isn't just so simple and easy as that. You would need a lot of money, a lot of time. If I had a crew of guys working on this thing would have been a fortune to build. Fortunately, I was here by myself with my skills and my tools, and I was able to do most of it, pretty much all except for some machining. But yeah, that was one lesson. Another one was don't let people tell you that your ideas are stupid. Now, if your ideas are stupid, I can't save you from that. But I was contacting a company for bearing. I needed a turntable bearing or an equivalent, and I needed to get one that was rated for this type of a project. And I wanted to try to save money. I didn't want to go wild with the spending. And this guy was rude to me. I wanted to source a bearing that had a certain rating. And instead of helping me find it based on the rating and the load capacity and the moment load and all that stuff, the guy was ignorant. Instead of sharing, he's like, I don't know anything about that, I can't help you. He started telling me how, oh, you shouldn't be building a stump grinder, you're just trying to reinvent the wheel when you could go buy a perfectly good grinder from these people I know. I've had stump grinders before in my lifetime, and they would have good prices for you. And I don't know why he tried to dissuade me, but he took a lot of wind out of my sails when he said that to me. But now, looking back on this, I mean, from where I'm at right now, looking back, I'm very happy I didn't listen to him, and I can't believe that I ever let him get me down that way. But this was never a sure thing, and so I guess probably with it never being a sure thing, I had to have doubts. I had to be honest with myself and know that there was a possibility that it would fail. But nothing ventured, nothing gained. People will always criticize what you're trying to do. I had people tell me that sounds really dangerous. You could kill somebody. You're gonna kill somebody. I had a friend who works in the industry, and he told me, he's like, dude, that sounds like a crazy idea. You're gonna kill somebody. What if your cutter head could just come right off and go flying across the yard and go through somebody's house and kill them? And I don't know what he thought I was going to use for bearings, silly putty. I mean, I don't understand like what was going to hold everything together, but that was what I got from my friend. And then other people said to me, "Whoa, that's dangerous. Whoa, I don't know about that, man. I don't know about you, Ed." You know, and it like, what can I say, man? You know, people don't want you to succeed. End of the day, you know, you can be very talented and have a lot of drive, but people are still going to be Debbie Downer on you and try to push you down because you're doing something they can't do. End of the day, they just think that it takes more than what you've got, and they don't know what you've got. They don't know until you don't know until you've done something if you know what you've got. Because what you've got is something you haven't yet done. That's the whole point. It's constantly surpassing your old boundaries, your old levels, your old abilities and skills, and your old ambitions. This is a new ambition. Think about it. I mean, I did borrow some stuff from other people, but I borrowed from people that really had it figured out. They were smart people. And there was not a lot of great solutions better than what I have here. These solutions are all good. Everything here is industry standard. But the difference is I paid what I paid for this thing, and everything here is brand new. And I can go back here. Everything is retrofit. Everything is self-made. So I can just take components from this and just make new components. It's not that hard. It's not rocket science. I mean, it is like scientific in a way because there's a process of discovery and learning, and then there's just dynamic, you know, things like the tensioning, the belt tensioning and stuff. But I can tell you, like, imagine the thrill of what they told me. Okay, I talked to Carlton Stump Grinder Company, and they make the highest level of grinders that you can get. And they are very durable. They last a long time. Very powerful machines, great machines. And the guy that I spoke to over there said you're going to have trouble getting that belt tensioned enough to run the load without squealing that belt out when you hit a hard spot in the stump. He said that's going to be one of the main difficulties is getting that belt tension right. So when I was out doing a stump and I realized I had turned that turnbuckle and made that spring tighter, and I realized that my system was working, the engine was bogging down. If the engine is bogging down, then it's working right because it's not squealing a belt. And as far as I know, that engine was running correctly. So this is a great day. You know, when I see this thing not burning out a belt, not smoking or, you know, squealing if it hits additional load, because that engine should die, and then you turn the engine back on and raise the cutter head and then take smaller bites. You don't want to be destroying components. This purpose of this engine is not for destroying parts. It's for destroying stumps, you know. But now it's here, and I want some stumps to grind, and I can't find any. You know, people are not really about stump grinding right now, and so it's biting me in the butt. But I have had a chance to grind a few stumps, and I have made good money doing those stumps. So that translates to me being pretty happy about the whole experiment. Things that I perceive to be pointless on other machines now make sense to me, you know, those ideas, because I have a problem with my belt being damaged. I need a shroud, because I hate shrouds. I think they're dumb, but when you cover stuff up like that, you keep it safe and clean, and then it runs better and works better because it's not all covered in dirt. So, you know, Vermeer is a good example. Covers and shrouds on everything, and they're such a headache to take on and off, and sometimes they never go back on the same. And you're just annoyed because the stupid thing wouldn't go back on the way it came off. You think it's going to go back, but it doesn't. And there's a little trick to it, you know. Oh, you have to make sure this bolt goes in first or something. And so I'm going to try to do it in a way that is kind of forgiving. My buddy who does heavy machinery knows a little bit about shrouds and stuff, so he told me what to do with that. So I'll hopefully have that stuff figured out here in the next couple days or maybe a week, but I have to get some fresh sheet metal, because if I use a bunch of scrap from out here that's all bent up, it's going to first of all have paint and stuff all over it and be hard to weld on, and second of all, it's going to be very irregular, and I need this to be perfect, because when it goes on, if it's hitting those belts at all, those belts are going to rub on that, and I won't know because it's inside a shroud. So just don't give up on your dreams, guys. If you have a vision of something that you're trying to do, make sure it's not stupid. I mean, make sure you have like a good idea. Thing is, like, building a machine is not the same as like, oh, I'm going to start a business. Starting a business is like endangering everything about your livelihood, right? You quit your job, you try to spend all your money that you have on a business, and if you don't get clients, you're ruined financially, and you got to try to sell out and get a job again. But if you build a machine that's a production work machine, at the very worst, you waste the money on that, and then you don't succeed, your machine fails. But as long as you have this fortitude and stuff to continue trying and throwing yourself at it, and as long as you've got some spare cash, as long as you've got what you need to keep feeding that hungry beast, you can do more with it. And I can tell you, like, it would be very easy for me to do another one of these machines now, because I could have a whole parts list and say, like, all right, this is what I need to buy, and I could just buy everything and it would all show up, and then I would just little by little do the process and everything would be here. I wouldn't be sitting here going, I don't know about the dimensions or whatever, I have to figure it out as I go. I would be already knowing it all. I could get the shivs, I could get the engine speed, I could get the ratio for the correct feet per minute on the cutters. I could know where to get the wheel from. I know how much it costs. All this stuff is knowledge. It's valuable knowledge. Now, I'm not starting a stump grinder construction fabrication business. You know, that's somebody else's territory. My territory is just building this cool machine and then watching it run and just being happy that I learned how to do something amazing. Because now that you've seen this, now you know you can basically do anything. You know, once you have like hydraulic systems, like pivot points, you know, ratios, like shivs, shafts, bearings, like once you know that stuff is available to you, it's not that hard to do something. It is expensive though. It is very expensive. I think I probably spent up to now probably like $15,000-$16,000 on this machine. It goes up all the time, but I keep detailed notes. Anyway, it's fine. You know, the way it plays out is it works really good as a machine for me. So as long as I have a great machine at the end of the day, really I spent less than this machine would have cost if I bought the equivalent, because there are some other machines out there, but they are kind of lesser machines. To be honest, they are not as good. They're not as rugged and tough. I have the turntable, that very wide sweep. That is special, you know, with this long head, like how this head is. It's so long and it has such a wide sweep. That's a very unique thing. That doesn't just happen for everybody when they have a grinder. Like some grinders have a very small sweep, and you would have to make repeated passes, or they don't extend very far. So 5 feet is basically a good standard, where now you've got this huge long piston and you don't want to go too long with it. 5 feet is a lot. You can do most stumps in 5 feet for sure. I'm planning on putting a mast on here at some point, which will just be like a piece of steel that goes up, not too high, but somewhere over here, and it'll have a camera, and then you'll be able to see. I think I want to have it on the other side because you'll be able to see more, I think, of what the machine is doing due to the fact the belt is over there. And then I'll be able to use that camera and actually do some controls inside the truck if I need to. I don't really know if it's a good idea to make a practice of it, but you can use it to back up and get onto the stump. And then, of course, if I just had a couple more passes, I could make those passes and then back up again, for example, and that would be no problem. But the 5 feet, really the camera would just mostly be for getting in position, because I don't think it's responsible to be over there and then looking in a mirror or looking in a little camera when there could be some kids in the yard or something. But it is a nice little fantasy. Like, what if I was in the field and there was nothing there, and somebody said, I want to do 100 stumps, and then I'm just driving the truck, just blapping stumps like a video game, and drive to the next one and then blap that stump, and I would have the engine running the whole time and something like that. You know, you would be like, okay, as long as you're really paying attention to the camera, because it's got a little display screen that's like, you can get bigger ones, but the one I like is about 7 inches, I think, and that one is going to show you all that you need to see for stump grinding, because really it's the sound more so than what you see. When you hear that engine bogging down, I mean, if you see that head like bobbing and chattering and then you hear the engine bogging, then you know you've gone in too deep. But anyways, there's no need for me to go on talking about this. That's unrelated to this creation. I wish you the best of luck out there. Have a great day. And don't forget to like, comment, and subscribe.